Dear students, now some more doubts of yours. First, why valency increases from 1 to 4 and then 4 to 0 for first 20 elements? The answer lies in their electronic configuration. See, valency depends on electronic configuration of an element, and electronic configuration depends on atomic number. How? Let's see. I said that valency changes in this pattern for atomic number 3 to 10 and then from 11 to 18. Let's have a look at their electronic configuration. These are the atomic numbers. This is electronic configuration and this is valency. So if atomic number is 3, configuration is 2 1. How? 2 electron in first orbit, because first orbit can have only 2 electron, remaining will go to second orbit. Then for 4 atomic number it is 2 2, for 7 atomic number it is 2 5, for 9 it is 2 7, first 2 electron in first orbit, remaining 7 in second orbit, and for 10 2 8. Now valency depends on number of electron present in outermost shell, that is valence electron. Valence electron is the term for electrons present in outermost shell because they determine the valency of the element. So 1 electron, 2 electron, 3 electron. If in outermost shell, then valency will be the same because elements with 1, 2 and 3 electron donate their electron during chemical reaction because they cannot have 7 or 6 or 5 more electron from some other element. So the only way they are left with is to donate the electron. If there are 4 electrons in valence shell, then valence shell means outermost shell. Outermost shell, then they have all the 3 options open. Some element share electron, 4 electron, some get 4 electrons, some give 4 electron, but in any way their valency will be 4. If the electrons are 5, 6 or 7, then they will not donate 5 electron or 6 electron, 7 electron because that is impossible to do and there is no need to do so. Rather than giving 5 electron, it's better and easier to have 3 more electron, either by getting from some other element or by sharing with some other element. So if one has 5, it needs 8 minus 5 means 3 electron more. So it gets 3 electron more from some other element by sharing or by getting directly in donation. So 3 valency. If 6, then 2 valency because it needs 2 more. If 7, then 1 valency because it needs 1 more. So it gets 1 more by donation by some other element or by sharing. What about if it is 8? If it is 8, then it will not need any electron because its outermost orbit is already having the octet. That is 8 electron which is needed for any element to be stable. That's why this element with 2 electron, that is neon, is a noble gas and its valency is 0. Now you can understand why it's changing like 1, 2, 3 because they are donating 1, 2, 3 electron, 4 because they are giving, taking or sharing 4 electron, and 5, 6, 7, 8 because they are getting 3, 2 or 1 electron, and the 8th one, no electron is needed. In the same pattern for 11 to 18, configuration will change like this: 2 8 1, 2 8 2. Why so? Because first orbit can have or accommodate only 2 electron, second can have only 8 electron because second orbit cannot have more than 8 electron. So third will have 1 extra electron. In case of 14, third will have 4 extra electron. In 17, the remaining 7 electron. In 18, 2 8 8. And with this configuration, the outermost orbit electrons are in the same pattern as for atomic number 3 to 10. That's why their valency will also be the same because valency depends on valence electron, that is electron present in the outermost shell. They have nothing to do with electron present in the previous shells or how many shells the atom is having, etc. Like all these are having 3 orbits, all these are having 2 orbits, but that doesn't make difference. The similarity is that all are having same pattern of number of electron in the valence shell. Therefore, their valency also changes like this: 1, 2, 3, 4, 3, 2, 1, 0. Okay. Let's come to second problem. What happens if a chemical equation is wrong and we try to balance it? Answer is that if equation is wrong. Equation is wrong means that either the formula of the reactant 1 or 2 is wrong, or the formula of the product is wrong. Like if you write rather than Na2SO4, if you write NaSO4 over here, or rather than H2O, if you write here H2 or H2O2, etc. In that case, in most of the cases, equation cannot be balanced only. And in some few cases, even if the different equation can get balanced, that does not make any difference, because if wrong equation is balanced, still it is wrong. So let's come to third question. Why do metallic ions and ammonium ion have positive charge? Answer is in their electronic configuration. Metallic ions have either 1 or 2 or 3 electron in their valence shell. And we have already learned in previous question that the only way in which they can react and can get configuration like noble gas is to donate their 1, 2 or 3 electron, and in this order if they donate electron, then an atom get positively charged. How? See here. Sodium, electronic configuration 281, atomic number 11, so it has 11 proton and 11 electron. That's why it is neutral. Atoms are neutral for having same number of proton and electron. Now if it gives 1 electron in order to become stable during chemical reaction, then now the whatever is left is having 11 proton and 10 electron. So 10 electrons charge is balanced by 10 proton only. Charge of 11 proton comes on this atom, and then this sodium atom is no more atom. It is sodium ion now. It is sodium ion now. In the same way, if a metal atom has 2 electrons in the valence shell like magnesium 282, then it donates the 2 electron of the valence shell. If when it gives 2 electron, then it will have 2 unit positive charge. Why? Because now it is having 2 electron less than number of proton. How? See, magnesium's atomic number is 12, so it has 12 proton, 12 electron. So it is neutral. After giving 2 electron, now it has 12 proton and only 10 electron. So charge of 10 electron is balanced by charge of 10 proton, and 2 extra proton charge, that is 2 unit positive charge, comes on this atom. And now it is not atom, because charged atoms are not called atom but they are called ions. Just opposite happens in case of non-metallic atoms, because they do not give electron but they take electron. When one take electron, then number of electron exceed to number of proton, and then in that case then it gets negative charge. Come to third question. One more thing, that what about ammonium ion? Ammonium ion is a different case. It is formed by combining with a neutral molecule of a compound called ammonia NH3 with hydrogen ion. NH3, as you know, is formula for ammonia. Ammonia is a molecule, is it a compound, and all atoms and molecules are neutral, so ammonia is also neutral. It combines with hydrogen ion and becomes, and as hydrogen ion is having 1 unit positive charge, so after combining as well, the same positive charge comes on it and it becomes ammonium radical with positive charge. It can be explained in a different way as well, but that is not for you, for higher classes. So let's come to question number 4. Sometimes we add and sometimes we multiply atoms during balancing. I don't find any puzzle in this. The thing is there that when we balance any equation like P2O5 plus H2O gives H3PO4, in this, when this is balanced, but suppose it is not balanced, then phosphorus, hydrogen and oxygen atoms, 2 phosphorus atom, oxygen atoms 5, and if it is not written 3, then 1 over here, so it would have been 5 plus 1, that is 6. What about here? Phosphorus 1 atom, hydrogen 3 atoms, oxygen 4 atoms. As it is having 1 atom, so it is has to be 2. That's why we write 2 over here. When we write 2 over here, then number of atom of each element get doubled, and that is the need of multiplication. Why we multiply? Because if one molecule is having a particular number of atom of each element, then 2 molecules will have double, then 3 molecules will have triple. So when we write 2 over here, then number of atom of each element change from 3 to 6 for hydrogen, from 1 to 2 for phosphorus, from 4 to 4 into 2, 8 for oxygen. When it becomes 2 for phosphorus, then it is okay. But hydrogen were previously only 2 this side. As you can see, H2O. So for making it 6, we write here 3. When we write here 3, then we have to multiply 3 with number of hydrogen atom and number of oxygen atom to calculate the total number of atom present in 3 molecules of water. So we multiply only for calculating total number of atom present in those many number of molecules, whereas addition is done for counting number of atom present in 2 or more different reactants, for counting total number of atom on one side. Like oxygen is present at 2 places, one in phosphorus pentoxide, one in water. So there are 5 atoms of oxygen and 3 atoms of oxygen. So 5 plus 3 is to be added to make it 8. Previously it was 6. Now after balancing it has become 8, as both the side number of atom is same now, so it is balanced. So the question is, when we add when a particular element is present like oxygen at more than one places, either on left hand side or on right hand side. And when we multiply, when there is more than one molecule of any reactant and product. In P2O5 we have not to multiply with anything. Phosphorus will remain 2 only, oxygen 5 only. But here we have to multiply because number of atom will get tripled when we write 3 before S2. Previously there are 2 atoms of hydrogen and 1 of oxygen. While in 3 molecules it is 3 into 2, 6 of hydrogen, and 3 into 1, that is 3 of oxygen. Let's come to last question. Is monoatomic, diatomic and triatomic and monovalent, bivalent and trivalent are same? No. Only the similarity is that mono means 1, di means 2 and tri means 3 for all these examples. But as the term says, monoatomic means having one atom only. Diatomic means having 2 atoms, and triatomic means 3 atoms. If we write polyatomic, then it will be more than 3 atoms and more than 3. And what about monovalent? Mono means single, valent means valency. So an atom or a radical having one valency only, is said to be monovalent. An atom or radical having 2 valency is said to be bivalent. An atom or radical having 3 valency is said to be trivalent. And that's all.